So this is it, people. This is the last lesson, absolute last lesson. We're going to talk a little bit about the limit of a function. We're going to talk about it quickly and get this lesson out of the way and done with, because yeah, I'm done. No more. I didn't even do up my shirt today. I'm just going to sit here with my Diet Pepsi. I'm going to chill. That's about it. We're going to look at like 3 definitions. 2 of them aren't even new. So enjoy. Okay, this lesson, there's really actually no examples of anything other than what's written on the sheet. So there's nothing to write, just watch. The first one is about one-sided limits, and we actually did touch on this in the last lesson. It was a little bit spontaneous on my behalf because I wanted to jump in and talk about 1 over x a little bit more. But the idea is that limits that can't be done or don't have a single answer can sometimes be done as one-sided limits. So we can't necessarily say what the limit as x approaches 0 of 1 over x is because it doesn't approach a single thing, but I can talk about what it does as it approaches 0 from the right side, the positive side, and the left side, the negative side. And that's where this notation, boom, right there comes from. The limit as x approaches 0 from the negative side and the limit as x approaches 0 from the positive side. And when we look at just one side of it, then yes, there actually is an answer to the problem. It's either positive infinity or negative infinity, depending on the side that we come from. And we talked about this several lessons ago when we talked about discontinuities. This itself is called an infinite discontinuity because it's a discontinuity that goes to infinity. Basically, discontinuous just means that the 2 sides of the graph aren't attached. There's a space that you can't get from one side to the other. The next thing I want to look at is piecewise functions. And again, going to go through this super quick. And a piecewise function is just any function that and now this one here, we can have one-sided limits that do match up. On the example I'm giving, they're different. The limit of that function as I approach, is that x equals 2? Okay, fine, I will draw it. I will pick up my pen and write. This is x equals 2 here. And we can see that as we approach from the left, we actually approach a value of -2. And as we approach from the right, we approach a value of 0. And that's it. So we have jump discontinuity, which is just something that is discontinuous. Comes up a lot in electrical stuff when you turn on and off currents. It isn't too common in the rest of the world. So this is a discontinuity because they don't match up side to side, but the limit as we approach one side and the limit as we approach the other side do both exist. They're just different values. And the last thing is the definition of a continuous function, which I think we all intuitively understand. It's a function that doesn't have breaks in it. To be more precise, it's a function that is continuous if the limit as x approaches a of f at x equals the function at a, which basically says that if I approach from any point from the left side and the right side, I approach the same number, and it is that number at that point. And a continuous function has to have that true everywhere for every possible value of a. If it's not true for every possible value of a, it's not continuous. Okay, seriously, was that not like the shortest lesson ever? Cheers to the last day. There's some homework questions there. I'm well aware you're not going to do them, but I'm going to tell you to do them anyway. You might actually see something interesting there. That said, I'm just going to sit here for a while to make this video seem like it's not 4 minutes long. I'll get my dog. Hey, sit down. Come here. Come here. Come see. Come here. Come here. Come here. Oh, there she is. There we are. There's my girl. It's the last day, you know. Might as well say hello to my dog. This is Sindel. Look at the camera, Sindel. Sindel, look at that camera. You don't know why you're here, do you? But you don't care. You can stay and watch if you want. I'm just going to sit here and pet my dog. Or you can work on the homework. Whatever makes you happy. Seriously though, goodbye. Go work on the homework.